Hey guys! So today you and I are going to talk about design decisions. So let's get into it. So the question in question was, hi Frederick, do you have examples of bad design decisions that you have seen were made upfront, which later on proved costly to change? Yes, many. Depends on what you mean by how costly, because you can see these things at different levels. The most expensive ones are usually at a company level, where you have entire systems that are poorly designed, like the overall enterprise architecture is bad. And the cost of that is usually measured in millions, if not tens of millions, depending on how you look at it. Both from loss of revenue and from cost of migration and things like that. It depends on how you want to calculate that cost, because it's a difficult thing to calculate the total cost of such a decision. And then you have the more close to home type of thing, which is of course for us software developers, where we might care more about costly design decisions within our own system or the group of systems that we're dealing with. And I've of course seen decisions that happen in both cases. So if we talk about costly decisions from at the company level, the most common one is almost always and I've seen enough examples of this now, where a company will buy a third-party solution or a service or something like that, get too heavily invested into the thing, and all of a sudden they get to this point where, and you can use this as this is my favorite red flag for literally everything when it comes to software development. It doesn't matter if it's at the company level or if it's at like a system level. Here's the trick. Try to make a simple feature request that seems obvious to basically anyone, and see how difficult it is to make that thing happen. My favorite one is ordering data or searching or something like that. This is the most common request anybody who uses your system has, where they want to know what the state of things are. They want to get some type of information. And you will know, if you have a decent architecture, if you can do that. But for most companies, it's usually the case that, especially for the internal stuff, where they have such a shitty architecture that they can't actually make that happen in a ready fashion. There's no way for you to get an oversight over what information is available, because the designs are so poorly made that they don't have an overview of most of what's going on in their system, or like they have no sources of data where they can actually fetch this information in a ready fashion, which always leads to the same sort of thing, which is what happens. And I've seen this so many times. They start having this idea that, well, we need that. We need to have A, B, and C, like we need to be able to fetch this information readily, but the way it's been designed is that they have these different silos of information. They don't have a platform mindset when they develop their systems. They have built individual systems that take part of the total problem, which are not designed to work in any way together. And then this next thing they do is that instead of thinking about a different architecture that actually will work as a single unit, they try to integrate these two systems, which inevitably fails, because what they fundamentally don't understand is that that is exactly the same thing as having two different companies, two different groups of people trying to make it's like trying to figure out how to make a motorcycle play nice together with a car in a race. Well, it might work, or like you can make it work, but it's sort of fundamentally two different entities that you're dealing with. Like they're sort of similar, but making them play by the same rules, that's going to be very difficult. because they're fundamentally designed in different ways. And the same thing applies here, where what companies will do is that they will either buy a system or they will invest in like a really monolithic super system of some sort, and that system becomes too critical, or they get so invested into it that the cost of changing that system, when you the thing that I just said happens, where you literally can't change the system anymore. You can't. It's cheaper for you to make other people adjust their workflow than it is for you to change the system. That's when you have a fairly severe problem, and this is a cost that is measured in millions, tens of millions, depending on how much, like how you want to measure it. And especially this is true when companies acquire other companies, or if, as I said, you buy a third. Like my favorite one is Salesforce. So many companies that go into, say, Salesforce as an investment because most of their sales department sort of know how that works, and then they get stuck in that basically what we call vendor locking, because they move so much of their process to the platform that when they want to do things in their own way, where they have other systems within their like ecosystem, they can't actually do a lot of the stuff they want anymore, because the way that Salesforce is designed, it does not play nice with one of their own systems, and now they have a problem. So now their architecture becomes a manifestation of that limitation that they have introduced on themselves. It's similar to, it doesn't have to be Salesforce. I mean, some companies who might be heavily invested in a CMS system or like or WordPress or whatever, where their needs grow beyond this off-the-shelf solution or this big in-house monolith that they have built, and now because so much is invested into that thing, they can't solve their own problems anymore. That's a very, very costly investment. At the system level, it's basically, it's my favorite example of that is when you have a similar sort of problem, where you have seen this 100 times as well in more than a few companies now, where you have a bunch of different APIs, and this is where GraphQL, for those of you who have been playing around with that, becomes really popular, because it's the same, it's just nice, very much nicer. I really like GraphQL for this use case, but the underlying problem is always the same. You have tons of different APIs that own pieces of a domain of some sort. These APIs are inconsistent. Some of them are good, some of them are bad. They don't have any like joint design, so the teams that work on them, they don't really think about anyone else. Like the data models are spread across the entire organization. And so someone will at some point say, let's put a interface on top of that. Let's create a collection API, like so that all the client systems only need to connect to one backend system. And what happens then is that you create basically just becomes a gateway API on top of all of these different backend APIs, and then you try to morph the data into the shape you want the client systems to have. Here comes the problem now. What happens is that you just put a layer of abstraction on top of all the mess that is behind the thing, but the fundamental underlying data structures that you're depending on are still in the shape that they are. And this, for those of you who have seen my other videos talking about data sources and stuff like that, you can think of a data source as a natural resource, as I like to make it an analogy to a lake. If you have direct access to the lake, then you get raw water, or like the freshest water that you can get. You can take that and you can make soda out of it. But if a company locks off the access to the lake and basically just allows you to only get soda from them, because they have hogged all the water for themselves, you no longer have the option of getting just water. You have to get soda. That's what's happened. When the backend system, like when you don't change the process and you don't change the way that the services are built or the models that they expose, then you're still locked down to whatever they want to provide. And even if you put an API on top of that, all the internal mechanics, how the API integrate, I mean, some of them work in a very different way from other systems. Those limitations, they just bubble up even to the client system anyway. And so if you want pieces of information that they don't actually provide, you still have the same problem. Sure, you have a nice interface, but the underlying limitation of building features, as I said, you can use that flag again. Can you actually make this thing work the way you want it to? Probably not. And adding an interface on top is not going to solve that, which is, as I said, this is just something that very often happens at the architecture's level, because it feels complicated and the cost of fixing the underlying problem is so high that they do this instead. Here comes the next thing. You do that, And after a little while, you realize that actually you need to do that again, because now you have other APIs like proxies on top of some APIs for some part where you're trying to abstract away this problem so that it becomes easier for the client systems to develop. And now you have more client systems, and then it just cascades forwards, because you fundamentally don't understand that if you want to fix the real problem, you need to make sure that the lowest level provides all the necessary information to the higher levels so that the correct abstractions can be created without the limitation of whoever is deciding to put another proxy on top, because those decisions that they are making might be right, which is exactly how this usually happens. You make decisions that are right for one system or two systems, and then a third system comes in and wants something, and then you have to add their features on top, and then the next system comes, and then the next one, and all of a sudden you're basically back to the same problem, where you have some type of super API or super system that is trying to do all the things at the same time. And the cost of making this fixable, it's basically the same problem, because the fundamental issue is that you're not willing to restructure the underlying data sources, those APIs that actually hold the data, that has all the input, for example, that everybody else depends on, because it's usually too costly, especially in larger organizations where you have like systems that are super old. And fixing this problem, you actually just grow the cost to the company by doing the thing that I'm talking about. It's like you're trying to cure cancer with aspirin. So what I want you to take away from this is that costly bad design decisions are usually very easy to spot. As I said, my favorite one is ask for a simple feature. I'm not saying that search necessarily is easy, but like take a pagination, sorting of data, like querying timeframes or things like that over a data set, and you see if people can build it. The only time that's going to work is usually if the only thing you care about is within the domain of one single system, where people are actually working, as I said, on one system, not a situation where multiple systems that are owned by completely different people needs to work together. That's very difficult to accommodate in most organizations that don't really work all that well when they design their systems. Because if you design two systems independently of each other and then you try to force them to work together, you usually need to rethink a little bit how you do work. But very few organizations take the time to actually understand that. And when that happens, you create a connection, a very awkward codependence, where the problem just continues growing, because now it doesn't become a question of how well can we make the system. It becomes a question of how can we make this work at any cost, and that couples you together, which further increases the cost when you realize that actually now we can't even build the things that we want. And for most organizations, they get the wake-up call. Not when they do this for their internal systems, which is usually the way that starts. It happens when their users don't like their system anymore. Because the thing is, you can do short-term wins for quite a long time. The problem becomes that at some point you might reach a level of quality where your customers and don't actually like your system anymore, and they don't like your products or so forth and so forth. When that happens, you're pretty screwed. Most managers in these sorts of situations, or like people in this situation, they just try to shuffle around the problem and try to come with new solutions, and then they say sort of like just ride the company downwards, because the company can't get out of this problem, because nobody is willing to fix the true cost, or like to pay the true cost of solving this fundamentally. And very few people know how to solve it once you're in that mess. Have a great day.